Illustrative Math, Algebra 2, Unit 7, Lesson 6 is called Areas in Histograms. All right, our goals are I can calculate a proportion of a set of data that matches a shaded area in a histogram, and I recognize the patterns or proportions that occur in distributions that are approximately normal in shape. All right, warm up. Go ahead, pause the video and give this a try on your own. I'll just roll right into it. So the first thing says find the shaded area between the function, the x-axis, and the boundaries x equals 1 and x equals 2. So x equals 1 is this vertical line, x equals 2 is this vertical line. So I'm going to kind of divide this up into two geometric shapes. So this is a square, so you can think length times width or just side squares. So it'd be 1 times 1 would have an area of 1. This is a triangle. A triangle is base times height divided by 2. So this would be 1 times 2 divided by 2 is 1. So the area of that would be 2 square units. Number 2, what proportion of the area between the function, the x-axis, and the boundaries x equals 0, that's right here, and x equals 7, right there, is shaded? So what proportion? So it's basically the shaded area divided by this total area in this whole region. So, this whole region here. Okay, so purple divided by total. Okay, so the purple section is 2. I'll put that on the top. And I'll put the total in green, I guess, on the bottom. So let me do this. Let me start dividing this up into sections. I'll put those back there. This is a triangle. Let's see here. If I go straight up here. Actually, I don't need to do that. I need to do that here. All right, I start finding all the areas. 1 times 1 divided by 2 is 1/2. Same idea here, here, here. This is 1 times 1 divided by 2. This is 1 times 2 divided by 2. That's 1. This is 1 times 4, 1 times 3, 1 times 3, 1 times 1. So let's add all these numbers up. Let's see what we get. So 0.5 plus 1 plus 1 plus 3 plus 0.5 plus 4 plus 0.5 plus 3 plus 1 plus 1 plus 0.5. I get 16. Okay, so 2 out of 16, and I want to do it in green. So the total was 2 out of 16, because this was the green area was the whole thing. So reduce that down, we would say 1/8. Okay. All right, so ignore the colors there. I already went through and highlighted each number with colors to help us with the next question to make things a little bit faster for you on the video. So let's read this before we go into the questions. It says, a publisher takes submissions for short stories to include a book. 200 stories are submitted, but the publisher needs to be aware of how long each story is. The way the publisher will put together the collection of stories, a page typically contains 200 words. The mean number of words for each story is 2,600, and the standard deviation is 400 words. Okay, so these are all the different submissions. There's 200 total numbers here, and it says how many total words each story has. So let's look at the first question. If a histogram is created using intervals of 200 words, what would be the area of the bar representing the number of stories that contain between 2,000 and 2,200 words? Okay, so the area of the bar. So what's going to happen is you're going to have a bar here on your histogram, and we know that the width is going to be 200 because we're going from 2,000 to 2,200. So the width is 200. We need to figure out how high it goes up. So we got to go to our chart here and count every word between 2,000 and 2,200. So I went ahead and I highlighted them in green. Okay, so go ahead, count up how many green dots there are. All right, and I already did that. So we'll go ahead and take a look here. There's 18 green dots. I put a little green there so you know which one is which. 18 stories in that interval. So the height of this would be 18. So basically 200 times 18 gives me 3,600 square units. So that would be my answer there for that. Okay. Hopefully that makes sense. Now, the next question, what proportion of the total area is represented by a bar for the stories that contain between 2,000 and 2,200 words? Explain or show your reasoning. Okay. So what we're going to need to do is we're going to need to figure out the total area. We know that the 3,600 would go on the top. So the total area would be 200 wide by 200 tall, okay? Because basically you'd have a bunch of other bars here is what would happen. You'd have another bar here right next to it. Let's say this one only goes up to, let's say this one only goes up to 8, okay? Well, if I took all the bars and kind of just like stacked them on top of each other, they're going to have a width of 200, and the height is going to stack up to 200 because this one was 8, and then we'll do more and more of those bars of different ranges. So basically the total area is going to be 200 wide by 200 tall if I stack them on top of each other. So it's going to be 4,000 square units total. So the total area would be 3,600 from this bar divided by 40,000 total, which gives us 0.9. Okay. What proportion of stories in this group contains between 2,000 and 2,200 words? So what proportion of stories? So this one's a little bit easier. We only had 18 stories out of 200. So we don't have to, we're not doing the proportion of area. We're just doing the proportion of stories. So that's 18 over 200, which is 0.9 again. How did the proportion of the area you calculated relate to the proportion of stories in the group that contain between 2,000 and 2,200 words? Well, obviously you look here, 0.9, 0.9, we're going to say that they are the same. All right, now here's a little picture of the histogram. I didn't want to show it to you right away, but this is how we did it. We did the 2,000 to 2,200. That got me to 18 right there. Like I was saying here, if I stacked all these bars on top of each other, they'd all be 200 wide and they'd go up to 200. Okay. All right. I'm going to keep that picture there to help us. What proportion of stories in this group are within one standard deviation of the mean number of words? Within one standard deviation. So if I go back here, if my mean is 2,600, one standard deviation, I put plus 1 SD, would be 400. So I'd be between up to 3,000. If I go back 1 minus 1 standard deviation, I'd be down to 2,200. So basically we're looking for numbers between 2,200 to 3,000. Okay. So what I did was color coded it. So it's going to be basically, whoops, wrong one. It's going to be all the blue ones. Okay. So if I go back to my chart and I count them all up, I circle them or I count them, all the blue ones, if you look at them, are between 2,200 and 3,000. So I count up how many there are total. And for the sake of time, I already did that. That's going to be 137 values. So 137 over 200 is 0.685 for that one. Okay. If I go to number 6, what proportion of stories in this group are within 2 standard deviations of the mean? So 2 standard deviations, I'd have to subtract another 400. So minus another standard deviation, I'd be down to 1800. And then if I go up 1, I'd be up to 3400. Okay, plus 1 standard deviation. So basically I'm going from 1800 to 3400. So basically what I did was the green ones were, let me go back. I think it was all the blue, green, and pink ones. If I go here and take a look at my color code here. So yeah, the blue, green, and pink are the 2 standard deviations. So if I go back and count them up, count all these up, pause the video, I think I'm going to end up with 192 values in that interval. So that'd be 192 over 200, which is 0.96. Okay. What proportion of stories in this group are within 1 standard deviation of 2400? Okay, so again, if I want to go back 2400, 1 standard deviation of 2400, so 400 either way, that'd be from 2000 to 2800 basically, which I probably have it written right here. So yes, 2000 to 2800. So I just counted them up ahead of time rather than go back and count them or color code them. So I'd go back to my data, I'd count up how many are within 1 standard deviation of there. So I'd look for numbers between 2000 and 2800, and I'd count 125 of them, and that's what I would get. Okay. Now on a graph here, if this is my mean, if I put my mean right here at the middle, my mean was, what was the mean? The mean was 2600. So go right here to, oops, didn't mean to do that. I go right back here to my mean, right in the middle. So 1 standard deviation would be, really, it'd be all this data that goes right there. So that's 1 standard deviation. Okay, 1 standard deviation on each way. Okay, so this is minus 1 standard deviation. This is plus 1 standard deviation. And then I got to go another 22 to 18 would be right here, all that data. So this would be my 2 standard deviations. This is plus another standard deviation. And this is minus another standard deviation. Okay, so really all my data is pretty much almost all within 2 standard deviations of the mean. This stuff on the outside is a very minimal amount. All right, next thing here. Company collects data from 10,000 websites about how long it takes to load the site. The number of seconds it takes to fully load the website is summarized in the relative frequency table. And then the relative frequency table summarizes it to the histogram. So these are kind of the same thing. This is actually a little bit better because, sometimes it's hard to see exactly how high these are. But my mean is 3 for both of these. So this right here is my mean. And then the standard deviation is 0.4 seconds, okay? So the mean is 3. All right. And then your standard deviation is 0.4, okay? So first question, would a normal distribution be a good model for this distribution to explain your reasoning? Well, look at your histogram and you see, yes, since the data is symmetric and bell-shaped, it looks like it's normal. What proportion of websites loaded within 1 standard deviation of the mean? So this 1 standard deviation, so on my graph here, I could say, okay, I got to go 0.4. So this is 1 standard deviation to the left, and then this is to the right. So really all these numbers. Now, it might be kind of hard and annoying to figure out exactly what they are. Like this one here looks like it's 0.16. And then these ones, they're going to be kind of hard. So it might be easier to just take the data from your table here. So basically, I'm going all the way down to 2.6. So I'm picking 2.8 to 3, 2.6 to 2.8. So I'm picking these numbers and adding them up, okay? Those are within one standard deviation because I'm going to go from 3.0 to 3.4 and the same thing the other way. So, kind of just like I did on the histogram, if I drew a box here, okay, this is each one of these is one standard deviation because I'm going 0.4 in each direction. So to answer that question, when I add those four numbers that I had, I get 0.6801, okay? What proportion of websites loaded within 2 standard deviations of the mean? So 2 standard deviations, again, on my graph, I'd go 0.4 again to the left, and then I go another 0.4 to the right. So it'd be all these numbers in these boxes here. And again, instead of like looking over here and adding them up and kind of like trying to figure out how high they are, it would be much more accurate to use the exact decimals on my chart here. So I'm going from 2.6 down to 2.2. Let me redo that box. So there's another standard deviation. And then I'm going from 3.4 up to 3.8. I'm basically just going up, 0.4. And then here I'm going down 0.4, down 0.4. So I'd add all 8 of these numbers up. Let's highlight these here. Add those all up, and that will give me my new answer. So add all those numbers and get 0.9523. What proportion of websites loaded within one standard deviation of 2.8? So let's go back here. Let's delete some of this stuff here. So 2.8. So one standard deviation of 2.8. So 2.8 is right here. So one standard deviation, I got to go up to 3.2. So basically, right here, these values get me there. And I got to go down to 2.6. Wait, hold on. Let me go back and let me read that. What portion of websites are within one standard deviation of 2.8? Yeah, so that takes me to 2.4. There we go. So one standard deviation each way would be these numbers plus these numbers. So add up those 4, and what do I get? I get 0.6264. All right, number 5. Compare the proportion of websites within one standard deviation of the mean to the proportion of stories in the submissions that are within one standard deviation of the mean number of words from the previous task. Do the same for the proportion within 2 standard deviations. So the proportions are both very similar for both cases. For websites, about 68% were within one standard deviation of the mean load time, and 95% were within 2. For the number of words per story, 69% were within one standard deviation of the mean number of words, and 95% were within 2 standard deviations. Okay, so so we had here's my 95%, and here's my 68%. If I go back here, here's my 96%, and here's my 68.5%. Okay. All right, so here's our 2 graphs kind of summarized there with the curve with a nice normal distribution. So last couple things here are synthesis. A biologist measures the stride lengths of a population of emus, I think that's how you say it, emus, the tallest birds in the world, and the stride lengths of a population of ostriches, tallest birds in the world. The biologist found that the stride lengths of both populations were approximately normally distributed. The mean stride length for the population of emus is 3 meters with a standard deviation of 0.5 meters. The mean stride length of the population of ostriches is 4.5 meters with a standard deviation of 0.75 meters. All right, so with all that being said, let's look at the first question there. Approximately 34% of the ostriches have stride lengths between 4.5 and 5.25 meters. Describe these values in terms of the mean and standard deviation only. What interval would represent a similar percentage of emus? So 4.5 is one standard deviation below the mean, and 5.25 is one standard deviation above the mean. For emus, a similar percentage can be found between 3 to 3.5 meters, since it is the mean to one standard deviation above and below. Okay, so think of it like this. My mean is 4.5. That's my mean. If I wanted to go one standard deviation, I would be up to 5.25. Okay, because I'm going to add the 0.75. And then here it'd be 3 is my mean. If I want to go up one standard deviation, I'd be up here at 3.5. Okay. All right, how can this percentage be seen using a graph of a normal curve? Well, there's a vertical line down the middle, then another vertical line to the right, and shaded between the two lines. Okay, so here's my picture. This top one is, let's see here, my mean's at 3. This is my emus, and this is my ostrich. Okay, so mean right there, 4.5, 1 standard deviation. Okay, same thing here, 1 standard deviation. Approximately 95% of the emus have a stride length between 2 and 4 meters. What interval for ostriches has a similar percentage? So if I go up, this goes from 3 to 3.5. It's almost like I'm going up to 4 here. That's another standard deviation. Okay, so I'm 2 standard deviations to the right. And then it'd be the same thing over here to the left. I'm going to go to 2.5 and then down to let's see here. This is, wait, hold on a second here. 3 to 3.5. Okay, that's 0.5. Yeah, so then I go 3 to 2.5 and then down to 2. Yeah, my standard deviation is 0.5. So that's going to get moved over a little bit. Sorry, it's not perfectly straight. There we go. So I need to go 2 standard deviations on this graph. So 4.5 to 5.25, 5.25. So that'll take me to 6. So right here. And then same thing here, I go down 0.75. So that takes me right there to 3.75 and then down to 3. So that would be between 3 and 6. Okay, so 2 standard deviations each way, right? How can this percentage be seen using a graph of a normal curve? The area under the normal curve is shaded, 2 standard deviations to the left and 2 to the right. So obviously I would shade the rest of this graph right here until I get there and until I get there. Same thing here, shade the rest of this thing. Okay. So back to our goals, I can calculate a proportion of a set of data that matches a shaded area in a histogram. And I recognize the patterns of proportions that occur in distributions that are, I think we're supposed to say, approximately normal. Okay. Okay. Man, that's terrible writing. Rewrite that. All right. So last thing, veterinarian finds that weights for the population of each dog breed tend to be approximately normally distributed. They know that the mean weight of beagles is 25 pounds with a standard deviation of 3 pounds. The mean weight for Great Danes is 150 pounds with a standard deviation of 20 pounds. The veterinarian finds that about 68% of beagles weigh between 22 and 28 pounds. What can this tell us about Great Danes? Explain your reasoning. So beagles, let's see here. Beagles is 25 for my mean. So if I go up 1 standard deviation, I end up at 28. And if I go down 1 standard deviation, I end up at 22. So that's how I get the 22 to 28. So within 1 standard deviation of 150, so my 150 for my mean, if I go up 20, that takes me to 170. If I go down 20, that takes me to 130. So that makes me realize that approximately 68% of Great Danes weigh between 130 and 170 pounds, since there should be a similar percentage of dogs within 1 standard deviation of the mean. All right. Well, thank you for watching this video. Hopefully you enjoyed it, and we'll see you next time.